Hello and welcome to today's class. Let's look at the concept of electrical dipole. By definition, a dipole consists two equal but opposite charges separated by a distance. The net force on a positive Q charge placed close to a dipole. Given a dipole plus Q and minus Q and a positive Q charge arranged in a triangular configuration as shown below. This becomes your electric dipole diagram. So given two charges plus Q and minus Q and a capital Q arranged in a triangular configuration as shown below. This man here is to be diagram for your electric dipole. Now in exam they might ask you that what does this arrow mean? If they ask you the meaning of this arrow, what does it mean? By the way, this arrow follows the concept of your conditions or perhaps the laws of electrostatics. The first law of electrostatics says that light tends to repel while unlight tends to attract. So in accordance with the first law of electrostatics, so this arrow here shows a repulsion. A repulsion in the sense that I have a positive charge attracting the positive charge. These two cannot attract. So it means what? They will repel. So this arrow here shows what? Repulsion. This one here shows what? The attraction. Why? I have positive charge, negative charge. They can attract. So light tends to repel while unlight tends to attract. So these two are attracting. I have the arrow here. This one shows what? A repulsion. That's like the concept behind electrical dipole. At this junction here, let's say we have to find resultant force on the positive charge Q. Let's say we have to find resultant force on the plus Q charge. So now this concept here, let me call this one here, let me call it R1, let me call here R2, let me call here R3. So this is Q1, Q2, Q3 in this sense. If I'm asked to find resultant force on the plus Q charge, that's your F1 resultant. So in this case here, F1 resultant is equal to F12 plus F13. Let's get F12. So F12 is equal to Q1, Q2 all over the magnitude of R12 all squared dot unit vector of R12. First priority, get this part first. Let's get R12. So R12 is equal to R1 minus R2. Let's get R1. R1 is your origin here. So that's 0 minus R2. R2 is here. From this R1 to get to R2, I have to move this way. This way here, negative of X, that's minus R. Get to yes, R. I'm moving negative way, that's minus R, I, X direction. This was going upward, that's plus L. This is a vertical direction, that's your J. Alright, I have this here. Next task here, minus gives plus, that becomes Ri plus minus what? Minus Lj. The value for R21 is equal to this. Let's get the magnitude of R21. The magnitude of R12 per se please is equal to the square root of R squared plus L squared. Each of the terms I have it please. Alright, for me I will have that the magnitude of R12 is equal to the square root, perhaps. Alright, the square root of r squared plus l squared. At this junction here, I can represent the value of r12 magnitude as being equal to square root in accordance to indices. If I have root a, this can be expressed as what? S power what? 1/2. So the root becomes r. That becomes in a bracket r square plus l square all to power root becomes r. So this is value for what? R12. Let's assume that let's assume that r has a value, l has a value. We will have squared and get the answer. But we're just doing the derivation, right? Do I have an answer this way? I've gotten r12 resultant, a magnitude. Let's get unit vector. Unit vector of r12 is equal to position vector of r12 all over the magnitude of r12. This one here is this. This one here is this one here. That's ri minus lj all over magnitude is this. That's r square plus l square. I have it placed. So the value for r12 is equal to this. Alright. All to power r, please. All to power r. Let's get f12 resultant. Let's get f12 resultant. So f12 resultant, f12 percent is equal to k, that's k, q1, my q1 yes, capital Q, that's plus q, q2 is your plus q charge, that's plus q, all over magnitude of r12, that's this, everything is magnitude, that's r square plus l square all to power r. By the way, I will square it. This one alone is this. This square here, I'll have a square this way. Dot unit vector is this, all the value here, that's ri plus lj, minus lj all over r squared plus l squared all to power half. Alright, let's get a value for f12. From there, simplify further. f12, simplify further. Simplifying further, f12 will be equal to kqqq, so I have kqqq all over, now observe, half times 2, half of 2, this one, that becomes r squared plus l squared. I have it this way, half times 2, that becomes half times 2. 2 times 1 is 2 over 2. I have 1 as my answer, right? So the 1 is here, dot r I minus lj all over r squared plus l squared all to power r. Let's get the final answer for f12. This is now equal to kqqq all over, now observe please, observe, go back to indices. If I have a times a such that here is 3, here is 2, what do we know? They are of the same base. Bring out 1 and add the power 3 plus 2. This gives a to power what? 5. I apply this indices concept here. This and this are the same, so bring out r squared plus L squared outside this way. Next task, the power here is 1, here is half. So half plus 1 over 2, that will give you 3 over 2. Combine these two, I have this dot Ri minus Lj. This becomes the value of the expression for F12. Let's get F13. Alright, so I'm saying this, please. Let's make the value for F12. So F12 is equal to KQQ all over R square L square all to power 3 over 2 dot Ri minus Lj. Keep it pending. Let's now get F2, please. F13, please. Let's get F13. So F13 is equal to F13 is equal to KQ1 Q3 all over magnitude of R13 all squared dot unit vector of R13. Alright, I have this one here. Get this part first. That's R13 is equal to R1 minus what? R3. I have this. Where is R1? Your R1 is here. That's your origin. That's 0 minus R3. R3 is here. So move this way down here. This way here is negative of X. That's minus R. Minus Ri. Moving downwards is negative of Y. That becomes minus, yes, L, minus Lj. Solving this man, minus is plus, that becomes Ri plus Lj. Minus is plus, I have Lj. So the value of R13 is equal to Ri plus Lj. Let's get the magnitude of R13. Magnitude of R13 is equal to square root of the first term R squared plus L squared. We settle this quantity as R. I have that the value of R13 magnitude is equal to R squared plus L squared to power R. Alright, I've gotten the magnitude of R13. Let's proceed in getting the unit vector of R13. Unit vector of R13 is equal to position vector of R13 all over the magnitude of R13. This is now equal to this one here is this, that's Ri plus Lj all over this one here is of course this, that's R squared plus L squared all to power R. In this addition here, let's put all this value in here and get F13. So I'll take this off. Let's get F13. This equal to K Q1 is this, that's your plus Q. Q3 is minus Q. So minus Q all over this one here is this. I have R squared plus L squared all to power R. Mind you, I have a square. Put a square here. Dot. This vector is this. So I have Ri plus Lj all over r squared plus l squared all to power half. From here, the value of f13, so f13 will be equal to k q all over this one here. As we said initially, this 2 here will give you r squared plus l squared all to power 3 over 2 as we solved initially for f12. So to save time, combine these two. I should have this as I explained initially before. So dot, this one here gives you ri plus lj. Alright, I have this place. We said half and 2 gives you 1. Remember 1 here, combine this and this together using your indices law. You should have this as we explained last initially. From here, so this is my value for f13. Now let's get f1 resultant by combining this answer and this answer together. Let's get f1 resultant. F1 resultant, this one here. So F1 resultant is equal to F12, that's your F12 plus F13. Alright. Putting your values there, this is equal to F12 is this, that's KQQ all over r squared plus l squared, r squared plus l squared this way. Sorry please. R squared plus l squared all to power 3 over 2 dot ri minus lj. This for the first one here, plus f13 is this, that's kqq all over r squared plus l squared all to power 3 over 2 dot ri plus lj. Alright, I have it please. Now the next priority here is to observe something please. In these two expressions, something is common. That's kqq all over r squared l squared to power 3 over 2. This one and this are common. Bring it out. I'll have that k. This is not equal to kqq all over r squared plus l squared. As you can see, look up please. I multiply kq minus q. I should have a minus value here. This minus should be here. Minus here. Yeah. Minus should be here in my answer. There should be a minus here, please. A minus. Minus kqq. Alright. Yes, from here, from this one here, it will affect everything. This here should minus. Alright. Let's get this. So this and this and this are common. Bring them out this way. So if I bring out this here, I'm left with just this. So I'm left with ri minus lj, right? In bracket this way. Plus minus is minus. These ones here are outside already. I have this one left. That's in bracket ri plus lj. Alright. I have this please. Proceeding from here, kqq over r squared plus l squared all to power, please, all to power 3 over 2, 3 over 2, 3 over 2 into, remove the bracket, ri minus lj minus ri minus plus minus lj. What do you observe? R plus ri will cancel minus ri. It's off. So I'll be left with, here it gives me minus Lj minus Lj, that becomes minus 2Lj. So the F1 resultant value now alright, F1 resultant now will be equal to KQQ, that's so KQQ all over R squared plus L squared all to power 3 over 2 into minus 2Lj. I have it please. Lj in the bracket this way. Next task please. Final answer becomes the F1 resultant value will be equal to F1 resultant will be equal to KQQ. By the way, number first, minus 2 out first, minus 2, then KQQ all over R squared plus L squared all to power 3 over 2 dot, and this was Lj in bracket Lj. This becomes the concept or the derivation behind electric dipole. So this is like the concept behind electric dipole. So I have minus 2KQQ all over R squared plus L squared to power 3 over 2 in a bracket Lj. This becomes the value of F1 resultant. In case you are given values in this point here, this is how you go about it. This. Alright. This is how to derive the concept behind electrical dipole.